Continuing our discussion of solving systems of equations. So we've graphed so far, which graphing works okay if it's all integers, if we know our solutions are integers, but it's a little time consuming to do. We've talked about substitution, which works nicely if one of the equations is easy to solve for one of the variables. So what if those two things are not true? If you don't know that the solutions are integers and you can graph very easily, or if one of the equations is not so simply solved for one of the variables, what else can you do? So we're going to talk about elimination, and elimination is exactly what it sounds like. You are trying to eliminate one of the variables from the system of equations. So we have three steps again here. We're going to write the system so like terms with the same or opposite coefficients are aligned. Next, we're going to add or subtract the equations, eliminating one variable, and then we're going to solve the equation that's left. So this looks a lot like our substitution. From here, it's pretty much like substitution. We're going to substitute the values from step 2 into the equations, solve for the other variable, and then write the solution as an ordered pair. So after this first part, it's pretty much like our substitution. So I'm going to look at these two equations. I have negative 3x plus 4y equals 12 and 3x minus 6y equals 18. Now what I want you to notice about these two equations is that they're in the same form, where we talked about slope-intercept form and standard form and point-slope form. They don't need to necessarily be in one of those forms, but things need to be aligned. So my x terms are aligned. I have my operations here, my addition and subtraction here is aligned. I have my y terms are aligned. My equals signs are aligned, and then my constants are aligned. So I want to make sure when I use this that my two equations are set up so that I've got things lined up. X values, operations, y values, equal signs, constants. From there, I then want to look for coefficients of variables that are either the same or their opposites, because what we're going to do is we're going to add or subtract them to completely eliminate them. So you'll notice here that my x variables have a coefficient of negative 3 and positive 3. And if I do negative 3 plus positive 3, if I add those together, they will be eliminated, and my x will have a coefficient of 0, which means that my x variable will disappear. So I'm going to add these two equations together. So negative 3x plus positive 3x gives me 0x. 4y plus negative 6y is negative 2y. And 12 plus 18 is 30. Notice my operations here end up in the same spot. My equal sign ends up in the same spot. X term, y term, constant. Now 0x is beautiful. That's exactly what we want to have happen. That's 0. So I end up with negative 2y equals 30. Notice my x value was eliminated. That's the whole goal here, to make one of the variables go away. I'm going to divide both sides by negative 2. I get y equals negative 15. From here, it looks like our substitution. I've figured out one of my values of my variables. I'm going to go back into either equation. Neither one of these is really super pretty, so we're going to have to do a little bit of work here. I'm going to plug negative 15 back in, again, to either one of them. And as I go through, I come up with x is equal to negative 24. So the solution of this particular system of equations is negative 24, negative 15. Again, I can plug those back in there and check that they work. Let's try one more. I've got 9x minus 2y equals 30, and x minus 2y equals 14. So we want to make sure they're aligned again. We want to make sure they're in the same forms. So I have x's, I have operations, I have y's, I have equal signs, I have constants. Okay, that looks good. Now I notice that the y's of my coefficient are the same. So adding them together, negative 2y plus negative 2y will give me negative 4y. That will not do what I want it to do, which is eliminate one of the variables. So in this case, I can subtract. Since they're the same, subtracting will get rid of that. Now, one of the problems that I find with subtraction is that since we're doing three terms here, I find a lot of times we do fine subtracting one of our terms. We do fine subtracting the term that we're trying to get rid of. But by the time we get to the third one, we forget we're subtracting and we add. So what I'm going to highly suggest is that once you decide you're going to subtract, I'm going to suggest that you change this to adding and change everything to its opposite. So I'm going to change this to addition. I'm going to change this to a negative x. I'm going to change this to a positive 2y. And I'm going to change this to a negative 14. Okay, so yes, I'm going to subtract, but I really just then multiplied everything in the second equation by a negative 1 so that I can add. And the only reason I'm suggesting that is because from here, it's all addition. We don't have to think about, am I adding, am I subtracting, what am I doing? It's just straightforward addition. So 9x minus x gives me 8x, 2y plus 2y gives me 0y, and 30 plus a negative 14 gives me 16. Now again, with subtraction, can you leave it subtraction? Absolutely. If you find you're nailing it every time, continue on. However, if you find that you're finding that consistently you subtract some and add the others, I highly suggest you change subtracting to adding the opposite. All right, so from here, again, just like we did before, I've got 0y, which eliminates it. I'm going to solve for x. I get x equals 2. And then back to, similar to our substitution, I'm going to go back into either one of the equations. This one looked a little friendlier to me. I put 2 in for x, and I solved for y and got negative 6. So that means my solution is 2, negative 6. Again, I should be able to go into both of these equations and have 2, negative 6 work in both of them. So another method of solving a system of equations, elimination, and we use elimination with addition and subtraction when I have coefficients of two variables are either opposites or they are the same.